Well, welcome everyone, and thank you for joining us for this session or this webinar on defining the future of additive manufacturing. Why Dendrite? Why now? I'm Todd Grimm. I will be your host today. I'm a 30-year veteran in the additive manufacturing industry, also an additive manufacturing consultant through my company, Grimm Associates. What we're going to do today is to add clarity to what Dendrite is all about and what they bring to the table, but more importantly, describe or elaborate on what that means for the future of additive manufacturing, how it can influence things, how it can affect things, how it can change things. Now, don't click off with that description, because I guarantee you this is not going to be a sales presentation. I cross my heart on that. I'm going to do everything in my power to make this a conversation that is very informative for each and every one of you. And we're going to do that also by having the opinions and observations of two third-party guests, meaning not Dendrite employees. We're bringing two individuals from the outside into the conversation to add the color commentary, to add the observations and insights on the question of why Dendrite, why now. Those are Ryan Palmer and Dr. Ryan Wicker. Ryan Palmer is with HP. He's a senior vice president. He's also the global head of software and data, 3D printing, and digital manufacturing. Now, he's worked for companies such as Adidas, Intel, Z Health, and has founded his own company called Innovative Wearables. For each of those ventures and his current one, what he brings forth is a background in data architecture, but crosses over into product development. And as he states, he's got a history of bringing life to products that are based on disruptive technologies. Our other guest is Dr. Ryan Wicker. He's with University of Texas, El Paso, or UTEP for short. He is an endowed chair, also professor of mechanical engineering. He's founder and director of UTEP's WM Keck Center for 3D Innovation. Now, that center focuses on the use and development of additive manufacturing technologies. Under his guidance and through the center has employed several hundred student researchers, many who have gone on to become additive manufacturing leaders. And last but not least, we have Harshil Goel, founder and CEO of Dendrite. Harshil is an inventor, mathematician, and engineer. He's got degrees in pure mathematics and mechanical engineering, and he's self-appointed, taking the lead to lead his team at Dendrite along the philosophy or question of what can modern software do to transform additive manufacturing? So with that, we're going to get started in our conversation. And to make this conversational, I'm going to surprise our two guests by asking a question of both of you. Go ahead and open up your mics. Is there anything I left out of your bio that the audience should know in order to frame your observations and insights that you'll be offering in this session? Did I leave anything out?
So I'll since you said my bio first, I'll step up and I'll elaborate that I think, when talking about a history of making products as opposed to doing innovation, right, you really need to think about how that product's going to land in an environment. When looking to disrupt that environment, you really have to understand that environment well, because, just adding disruptive value while overly disrupting, how that affects the entire value delivery chain is a tough equation. So I think innovation for innovation's sake or disruption for disruption's sake is not the approach that I've taken in my career. And it's really finding what are those next level disruptions, and then what's that delivery mechanism about how they land to find full effect in that industry, which may change over time. But I think that's apropos for what we're going to be discussing here. And I think that's a little extra insight into where I've spent a lot of time across industries working.
Excellent. It's excellent background. Ryan Wicker, anything to add?
Yeah, good morning, Todd. Yeah, so thanks for that introduction. My background, my research work originally was in fluid mechanics. So I was new to additive manufacturing in 2000. Back at my days in graduate school, we hired away one of the early pioneers in additive manufacturing. And so I was immediately taken, much like everyone even still today that sees the technologies, inspired by them and what they could offer. So I came back to El Paso, my hometown, in '94, started another lab, another center, and grew into this one in 2000. So been pursuing additive manufacturing for over 20 years now. Like Ryan Palmer said, our innovators, we are a quite applied and innovative center, but all my innovations are through my students. So I am an educator. We use these technologies in creative ways. We do have our own patents and inspired in hybrid technologies to combine machines together. We were inspired by the ability to combine different materials together using these technologies while you additively fabricate. So we've always been inspired by the possibilities afforded through additive manufacturing. So I come to this as an educator and really kind of a longtime user through many innovations and offered through my students.
Beautiful. Thank you very much for that. Harshil, do you want to elaborate?
Yeah. So my name is Harshil, as you mentioned. My background is in math and mechanical engineering, but I think that's actually could be described as the background of the majority folks in our company, right? Our company's sort of manifesto or mission is to sort of help elevate the entire industry by honestly elevating all of the core foundational mathematical pieces that go into making this industry function. So yeah, I think I think this. I'm really happy to have the other two folks on the call here. I think that they both provide a unique perspective on how this industry needs to evolve and change, and sort of they're honestly giving us already insight into what we need to do in order to go make them happy. So thank you all for the opportunity here.
Beautiful. I want to continue with you, Harshil. So my assumption is there's a lack of clarity on exactly what is Dendrite, and what do you offer? What can the additive manufacturing community use or leverage from Dendrite? So first, there's two questions here. First off is there anything else you want to elaborate about Dendrite, what it is? But then the second question is exactly what are you bringing to the market to induce or possibly induce transformation? Because I think there's a lot of, it's a bit opaque. It's not real clear what Dendrite's all about and what it's going to be bringing to the table. So please, both of those questions.
So in one kind of maybe opaque sentence, Dendrite is a company that is trying to basically become the math department for the planet, right? And in a less opaque sense, it is a creator of software technology. And we have one key piece of software technology, namely our geometry kernel or engine. And the idea is that these geometry kernels and engines have not been dramatically changed over the last 2 to 3 decades. And basically it's time for a new one. The fact that they haven't been dramatically changed in the last 2 to 3 decades means that they're set up for legacy computer architecture, legacy manufacturing needs, and legacy design needs. And the idea was by using modern computation practices, like for example, using the GPU, by binding it to Python so that it's more democratized, and by taking sort of a very open approach to how we conduct business, we can use this key core foundation to elevate this technology, right? And so the folks who might use this kernel or engine will use it to go make, for example, their printers faster or better. They'll use it to create software that processes data that goes to these printers, or they might even use it in MES or simulation software, again, to do all the heavy duty number crunching from a geometric standpoint. So we are a provider of key foundational geometry software meant to elevate machine vendors and independent software vendors.
Okay. So now you made the statement, legacy hardware and practices and software, but you also said legacy kernels. In my mind, something like a kernel doesn't really exist in the additive manufacturing data flow. Am I wrong on that? Would you be the...
So geometry kernels and engines actually exist in everything that anyone is dealing with, right? So regardless of whether you're using mesh-based software or CAD database software, there is something doing the mathematical computation in the back, right? Unfortunately, the majority of all that computation right now in additive land is done on mesh-based representations. And so the idea is, yes, there are existing solutions out there, but the key fundamental reason for this change is data, right? The idea is here is that all the printers are increasing in size, they're increasing in precision, and so now we have a data problem, right? And so to handle these new issues going forward, we need a much more efficient computational backbone to manage this data.
Ryan and Ryan. From here forth, I'm going to say Ryan P for Ryan Palmer and Ryan W for Ryan Winker. Any agreement or disagreement or additional commentary on what Harshil just said about the kernel concept and legacy?
No, I think, you know, while I haven't spent my entire career in the additive manufacturing space, you know, I think you can choose to look at that as a shortcoming or an advantage, depending on how you're really seeing things. And so, what do I bring? I've worked across many domains in my career, and what do I try to bring to each of them is some first principles thinking. So understanding and having a background in compute architecture, and my time at Intel, I know how powerful getting the right, you know, environment to solve the problem is, and was really, you know, enlightening to see the history of computational geometry, the history of how the companies and the approaches to that solution have kind of evolved over the years, and then recognizing that I think to really unlock the power of additive, we're just scratching the surface of the level of complexity, the level of detail, the level of data that's going to need to be processed through these systems. And so choosing you know, a compute architecture that allows for forward-looking scale is a really interesting fact. So I think Harshil fully aligned with that forward thinking that Harshil's just shared with everyone.
What I would add, Todd, is as a longtime user, there's many CAD packages, many preparation packages that we use. So the workflow it works, but it's somewhat cumbersome. And so, you know, we talk in this industry about complexity for free. I'm not so sure, at least from a laser powder bed, metal additive manufacturing perspective. We have this, what we call at UTEP, this global test artifact data exchange program.
Yep. Yeah. Hold it in front of your face there. It was.
Yeah. So this is built on a vat photopolymerization machine, but this is built. This we use. If you go to keck.utep.edu GTAD-XP, we are looking at building across platforms, being able to build the same part, and just this part here, when I build it within the UTEP Keck Center, we have 5 different just laser-based metal additive manufacturing machines. And the time to build those parts is all different. So the scanning strategies, the internals of all this software is in many respects a black box. And so if we could have this single system where we would have control over that and be able to build the same part across platforms, that would be a tremendous disruption in the industry.
So now, Ryan, help me connect the dots on that, Ryan P or Ryan W. With this black box concept and too many different systems, what is your vision of what Dendrite could do, or what could be built off of the Dendrite backbone to facilitate easier transfer of data or visibility to what's really going on in that black box?
Yeah, so
I'm not making the connection in my mind.
So, so we're new to Dyndrite. We're weeks old in working with them, and we're very excited about what they offer. But let me just stick to metal laser additive. And if you were just to look at an individual layer after you prepare that file, the scanning strategy for each one of those layers is different. The amount of time, for example, when a laser jumps from one region to another, there's a little delay there, and that time and all that builds up. So on one system, just building this very small part, if I were to just build a block, I could do it in 3 hours. When I build this complicated part, it takes 11 hours. On another machine, it takes 23 hours. And so there's things between those that are different, and you don't really have access to understanding what that is. So I believe with Dendrite, And the preparation things is we get into the scanning strategies and control them. When we define regions and control those scanning strategies, and we can hopefully have the same process occur between technologies.
Excellent.
To add to what Ryan is saying, what he's alluding to is the fact that one of the key APIs that's offered by our kernel is a full-blown toolpathing API, right? It's meant to be able to take 3D geometric data, slice it up in whichever format you want, whether it be polygons, splines, or pixel data or voxels, and then provide key transformations and APIs so that anyone can define their own toolpaths regardless of the machine type, right? So that's one way that a number of people are interested in using our technology.
Excellent. Well, I'm going to, building off of that API, toolpath API comment, I will also want to take us back, and again, just for clarity, to be the last clarity point here, and I believe you said it, but I want you to explicitly state it. So in describing the Dendrite solution, like you mentioned MES. So I just want to clarify, you are providing the foundation upon which something else will be built that then is either in that MES system or interfaces with that MES system. Is that correct?
Yes, that's correct.
Okay. And then who should be knocking on Dendrite's door for solutions? I mean, are you offering a product that a manager of an additive manufacturing lab can call up and get a license key for it? Or to whom are you offering these solutions?
So the key folks that we're talking to, one, of course, you can look at the Dendrite Developer Council, right? We have a number of OEMs and ISVs, right? HP was the first to be on the council as a machine vendor, but we also have folks like Ansys and Altair on there. So it's machine vendors, it's software vendors, and the third category I'd sort of give is what I'd call advanced users, people who want to not only use the software that is built upon our technology, but people who want access to the guts of our technology so that they can do key defining research. For example, what Ryan was talking about, right? Where, again, it would be cool to have, for example, build prep software built on our kernel. But what Ryan needs in order to do research is low-level access to really push the limits of these machines, right? So it's the machine vendors, it's the software vendors, and it's the folks who are trying to really push the limits of what they're trying to do, right? And the reason that they're using it is because we interact with the CAD data natively, we are GPU accelerated, and we are, quite frankly, accessible from an iteration standpoint.
Okay. And the clarity, I think we've cleared things up, because I think people walked away with the CAD, direct from CAD concept, GPU accelerated to give you more oomph, more processing horsepower for speed. The other thing you've mentioned in the past, or Dendrite's mentioned in the past, is Python or Python enabled, which we'll get into Python a little bit, but those are, I believe, the three key elements plus the kernel itself. Those are the 3+1 elements that are foundational to the Dendrite solution. Is that correct?
Yeah. And what they're meant to do is they're meant to enable much more sophisticated machines, much more sophisticated prints, and honestly, much more sophisticated scanning processing strategies, right? So the goal, again, is truly to elevate what everyone else is doing.
I like that statement. Can I quote you on that? Elevate what everyone else is doing. I love that. So now for roles or relationships with Dendrite, Ryan W. has already explained, he's more of a user, as a research organization, practical research, but more of a user aspect and exercising the platform, the technology. Ryan P., can you explain what the relationship is with Dendrite? Are you a user? Are you part of the Dendrite Developer Council, or is it something else?
Yeah, so I think I'll frame it in the sense of, HP as a company is a large entity. And so, when HP enters an industry, there's a push for scale and success and growth that, I would say isn't really present in a lot of the other companies in this field, right? So in our attempt to really get, this industry to scale like we like it to, there's an understanding that there's so much opportunity here to solve some of these fundamental problems, right? Such a small amount of products and parts are designed for additive, right? It's absolutely minuscule. So the opportunity is so outsized compared to where we are that, you know, that's the fundamental mindset that we go into a relationship with Dendrite. We have many other partners that we engage with, and, you know, I see and HP sees Dendrite as another key partner to help build that set of capabilities that's going to really let us unlock scale in this industry, because there is a big disconnect between how things are designed and then how they're made, right? As you go from art to part, there's a lot of pitfalls that you can fall in, right? And that's simply taking a design and printing it on this printer versus that printer, or how do I improve that part once I see how that first print comes out? There's just so many manual iterative processes, and so getting some technology that helps us begin to automate, begin to create some next level capabilities, and just help mature the industry overall for these types of flows that are going to be, they're going to need to be matured for us to start taking significant mind share away from designers who are building products today without even thinking of additive. So I think that's the overall thrust. So Dyndrite is this important technology partner for us that is another tool in the toolkit as we try and solve problems that'll, again, get this industry to scale to the level that HP is really excited about.
Excellent. I promised that was the last of the clarifying statements just a few minutes ago, but I'm going to go back. So primarily Ryan W., you gave us a hint that it's more than addressing the front end processing. You're talking about, you know, black box and getting in there so you can control very fine elements of the build itself. So I just want to clarify. So we're talking about, it could be for front end processing, it could be for handling machine operations, but I want to ask, well, we mentioned MES. Is there anything else to the breadth of what this Dendrite solution could address in the entire workflow? From, you said, you know, art to part, but all the way out to logistics and distribution and legacy and all that. Does it have a play well beyond the physical aspect of building something and monitoring that build process to feed into your MES systems?
Is that for Ryan W. or Pete?
That's for anyone. You know, this is an open conversation, so feel free to speak up.
So I just wanted to throw out there, and Harshil can actually come in and fill in details. So we're new users here. Just yesterday, my students went through a little training on Dyndrite. And one thing, for example, that we're doing, we're in the midst of a comprehensive project with NASA where we have to track every single part and every single build. And so we're labeling those things. So just adding a label to each part when you fabricate is a complicated thing. And they went through a process yesterday in their training where it just became seamless through this, their Python script front end. And so Harshil, I don't know if you can maybe elaborate more on that, but that was a very powerful thing, at least from my students' perspective.
Yeah. So that's actually, it's funny because that labeling concept has been sort of the key thing that a lot of folks have focused on, even since we, you know, sort of announced ourselves at AMUG last year, right? I mean, whether it's the labeling or the tool pads or the moving around or the key nesting aspects of, you know, what our kernel can do, right? I think the name of the game is automate away all of the tedious work, right? Like if you have to spend time printing cubes and you just to, you know, test out laser scan strategies or things, you cannot possibly do that one at a time, right? And have that happen in any reasonable amount of time, right? You have to figure out ways to remove the work that's not necessarily major value add and can be automated, right? And so I think that's one key aspect of it. The second is the minute you, for example, get the CAD data, you can start to use a lot of the metadata behind the scenes to, again, drive some of these automations, right? So a number of things that I think people take for granted right now, just because they're using slow STL-based software, actually completely open up just by taking a slightly different perspective to the workflow. And when I say workflow, I mean all the way from getting geometry, analyzing it, putting it in a database, processing it for a build, then doing post-processing all the way down to the machine. So yeah, no, I agree with you. I mean, the labeling is one key automation that a lot of people seem to really like.
Back to Ryan P. So I'm going to put you on the spot here and do the best to tell us what you can, because I suspect that it's intentionally holding out. So you were announced, or HP announced, a partnership with Dendrite. What was it, 2, maybe 3 weeks ago in a press release? You've told us the challenges you see and what you think Dendrite can help solve or fix or address, but is there anything you can offer us about what you plan on doing with your partnership with Dendrite? You can say no. Please feel free to say no if I'm putting you on the spot.
No,
but
no,
I think there's a little lack of clarity there also as to this.
appreciate being put on the spot. Let's just say, right, so to go back to that issue of scale, right? I think it's you know, the market or the set of capabilities that we bring to bear to help customers scale needs to grow. I think the opportunity is too large, and so partnership with Dendrite was indicated to let the industry know that these types of capabilities are, you know, part of HP's toolkit. So in the not too distant future, we'll be able to talk more specifically about how we think those capabilities should be brought to market, right? Having these amazing capabilities that we're talking about today is just one step, right? But again, you got to find that right vehicle to deliver disruption. And so, you know, I think that's the clarity that you're looking for, but that's the level of clarity that'll have to wait just a little bit longer, because again, there's so many different exciting problems to solve, and getting that right vehicle is really the secret to solving them in the right way. So
well, fair enough. You gave us enough to tantalize us, I'll say. But so thank you for that, and can't wait to hear what you have up your sleeve, what will be rolled out. I'm going to keep you on right now, Ryan P. Dendrite had what was it, March, April, Developer Council Day. There was a 2-day virtual event. You keynoted it. Then you joined a panel at the end of that 2 days, and you made a statement about, you know, what the big challenge was scaling up, or challenges in general, is the disjointed nature of software. You know, the number of software applications or programs that you have to use to get from point A to point Z. And Ryan Winker, you've already touched on that with, you know, mentioning lots of software. I'd like both of you to elaborate a little bit more on what challenges, you know, paint a picture around this disjointed nature of software, multiple packages, and what challenges it creates, and then bring it back to, again, I'm trying to get my head around this, how what Dendrite brings to the table can help fix that. You know, I'm going to answer my own question there, rhetorically, but is it that Dendrite has to conquer the world, therefore you only have a single platform? You know, that's an extreme, and I doubt that's the answer, but could you assist a little bit in describing the environment and how you think this will play to fixing that disjointed nature of software flow or data flow?
So I'll offer a first pass at that question. So, you know, we have a tremendous number of printers out in the wild producing or attempting to produce a tremendous number of applications, and the variety of how those applications are defined, what tool chains they're using, what data is available, the definition of quality for those parts, right? Whether it's mechanical, dimensional, look and feel, it's just a tremendous amount of variables, and there's very little consistency where we can rely on, you know, a stable path that a customer might take for application development into our machines. And so, you know, there's companies that have been attempting to kind of solve that challenge for a long time, and those solutions aren't bad, but I think just the fact that these are machines that can print anything as long as you get the right ones and zeros into them is a really important fact to keep in mind, that the hardware is more capable than our ability to drive the hardware. Okay, and I think that speaks to the disjointed nature of those solutions, that really the only applications in additive that have scaled broadly have been, you know, eventually bespoke solutions where they've really spent a ton of time tailoring that workflow to go from data to design all the way through manufacturing. And so, HP relies on partners a lot to make sure that that data coming into our machines is what it needs to be. But just the fact remains that the surface area of the applications that people are driving on our machines is tremendous. The applications that people are driving on all additive machines are tremendous. And so again, market maturity, starting to move to types of technology, starting to look at enabling a more continuous workflow, where even if this application and this application both add their special sauce, you still have a continuity of what that outcome is, how it's defined, how you're going to go about processing it is critical. And so I think, HP getting more involved with how content is prepared for additive machines is just a necessary step, because again, the opportunity is so huge. We can't simply always rely on third parties to do that at the exact rate, with the exact focus on the exact applications that we might be focusing on for our business, right? So that's where I think that this is one of the fundamental problems, and this is a kind of next step in how HP's intending to help that solution overall for everyone.
Right, Debbie, comments?
I'll add a little bit to that. So, so our product in education are students, right? So the bottom line, purchasing all these software packages and everything that's available, we invest a lot in software. So, there are issues that we have to deal with on a regular basis just in native CAD, backward compatibility and things like that. So as a university, we have, and it's not free, right? So it's still an issue, but I can imagine if I'm a mom and pop shop trying to make a business and investing in all these different software packages, they could not afford all the software that I have in my center. It's very expensive, and you have to keep up to date. But so with that said, it's not, Dendrite can speak for themselves. I don't think they're competing with native CAD per se, but you bring that file in and you can manipulate it. And so the beauty of their software, and Harshil talked about it some, is from the automation side. If I bring that package in, I can automatically generate this Python code. Let me talk for a second just about Python. So there's probably not a mechanical engineer that graduates in the country that doesn't know MATLAB. And so MATLAB and Python are in the same family of software, and many places are transitioning to software. The beauty of it is it's, I'm on calls daily with my students, and they're flying through MATLAB code to generate plots and do data analysis and all sorts of stuff. So the ease of use is incredible. So at the front end of their software, they're automatically generating this Python code that, from an automation perspective, you can now automatically, you have all that written, and so the next file you bring in, all that's automatically applied to it. And so from an industrialization perspective, the point here is that if you're able to repeat these processes and do similar things, then now you're presumably making the same part. They're breaking up things into regions and applying, I'm stuck on metal laser-based additive, but applying different scan strategies and support structures, and you can define these regions and generate this automatic code to do it, and then you can go in and edit the code. So the access to that code is very powerful. I think, Todd, you were focused mainly, or asked more about compatibility, but I think Harshil will speak more about their compatibility with all these other programs. But I think their intent is, again, we have to design these parts to take this art to part kind of thing. You got to be able to design it. So my own children, I'm forcing them to learn CAD and learn Python coding, right?
Wait, did you say your own children?
Yeah, well, they're not young anymore, but yeah, my kids are 21, 19, and 17, and yeah, I tell them the future is if they can design part, they need to be CAD experts. And in fact, my oldest son during COVID had started and spun out his own company. Go to 3dcastling.com. He's got his own company he started and founded in the garage, and now he's back in college. But the point is that you know, even you look at AP programs down in high school, people are screaming to use Python. So I think Python is going to be the leveling playing field. All these new generations of people are going, know how to program, and having access to that are going to make these things and rapidly innovate and make these programs widely accessible and able to reproduce these parts across the globe. So Harshil, I don't know if you want to compliment or add to what I just said.
Yeah. So, I mean, I wholly agree with you, Ryan. I mean, so for folks who don't know, I actually used to teach the MATLAB and Python class while I was a graduate student at Berkeley, right? And while MATLAB is a paid piece of software, Python is absolutely free. Anyone who's listening can download it for free right now at python.org. And Berkeley was actually sort of in the middle process of transitioning from MATLAB to Python. But the key, regardless of which language you're talking about, is it offered folks a very powerful way to interact with the data. Right, and that's sort of the crux of it, right? And sort of beyond that, right? I mean, it goes much further than taking something that used to take 70 hours to slice and doing it in under 12 minutes or whatever, right? Like those are all things we can help on that. But I think the key here is trying to use the kernel to untangle an unnecessarily complicated workflow, right? Because both folks have mentioned lots of software, right? Like you use your CAD software to design something, then you immediately ruin it by exporting an STL mesh. Then you have to go fix that mesh because why not? Then you have to go process all of it, slice it. Then you have to bring it into your own custom printer software to then do the final post-processing for the machine. And eventually you might actually print something, right? Like each of these steps, each of these interfaces cause you to work as if you're like walking through molasses, right? And so the idea is, okay, there has to be a better way. And in order for additive to go think about where it needs to be in the next 3 decades, we have to fix the key fundamental things that are slowing us down, right? And so Ryan, to Ryan's point, one of the keys is this automation and control that's unlocked through Python. But the other part of this, to Ryan P's point, is having a good, nice, direct connection to the design end of the world. So we don't compete with any CAD software, but the idea is to improve the communication between the data that's generated there for processing. So kind of all across the board, we care about reducing times, improving iteration, and honestly giving people more control over how this data is transformed and manifests in the machine.
Question came to mind. Well, thank you very much for that, Harshil, offering that clarity. But question that comes to my mind, you very early in that discussion right there, you said that you break the CAD data as soon as you go to STL file. The question popped up in my head: if adopting the Dendrite solution and building applications on top of that, does that preclude the use of other other methodologies for communicating that data to an additive machine? I'm thinking 3MF, and other file formats. So would Dendrite be able to play nicely if it were a 3MF play, or does it totally push that aside? Well, you don't, I've answered my own question. Here on live TV, I make a fool of myself.
Ladies and gentlemen, Todd just had a light bulb moment.
Oh, geez. We're talking automation here. I want to go to Ryan P. Boy, am I embarrassed. Am I blushing? I want to go to Ryan P. You made a statement when we're talking about this in preparation that digital manufacturing does not translate directly to or mean automation.
Yep.
That struck me. It's so obvious, but I've gone along with a bias. Can you elaborate on that? And then, kind of fill in the blanks in the automation conversation about how what you're doing could get us there.
Yeah, absolutely. So that is, I think, a bias that I brought in, right, when I entered this industry and started learning about digital manufacturing. You just have this natural association that if it's digital, it's automated, and that, you know, access to the data to make decisions is there today, but the humans are the ones making the decisions. And I think the challenge isn't that the humans are making these decisions for the first time, it's that they continue to then make these decisions over and over and over again, right? So I want to us and as an industry to move to a place where humans are making these decisions the first time, and then they don't have to keep making them, right? We have the systems in place to then automate those right decisions. And those right decisions depend on a lot of things. They depend on, you know, what your definition of quality is, what your source data is, what your you know, target process is. And so I think you know, I see Dyndrite as a technology platform where, you know, these types of decisions can be effectively output and realized, right? I think there's many people coming together that have interests in advancing aspects of this. And so, you know, I think for applications where native CAD is the source, yeah, why would you translate out of native CAD just as a matter of fact, right? I mean, these are the types of things that when I came into this industry kind of struck me as, well, that's an artifact of history as opposed to a conscious decision going forward where you can really put your finger on why that makes sense. But for other applications, all you have is scan data, right? You have point clouds to base it off of. So I think, you know, the protocols need to be flexible, but the way that those decisions are made and where they're made needs to be intentional. And so I do think that ability to script, you know, when you get a language that's as supported and robust as Python is, what you're really doing is you're connecting all of the data from your plant, all of the data from your university, all of the data about you know, what a human would be looking at to make the next decision and what mouse button to click in a UI, right? You now have access to those same types of faculties to make those right decisions in an automated way. So I think other industries have embraced this type of paradigm, and I think, you know, healthcare and manufacturing are probably still two that are lagging behind some of the other industries. So I think it's these are the types of technologies that I think give us an opportunity to move the needle forward in a meaningful way.
Excellent. Thank you for that.
I wanted to add that, you know, one key element to what Ryan is talking about, right, from the automation standpoint is groups of folks agreeing on how we're going to handle things, how we're going to do handoffs, and how we're going to manipulate and look at these types of data, right? So for example, you know, and this sort of kind of brings up that question of like standards, for example, right? Mm-hmm. So even Ryan W. earlier mentioned, they're trying to create a standardized way of being able to evaluate machines and, you know, test whether or not they're printing correctly, right? You know, with the artifact that the Keck Center is making, right? The same goes for us, right? Like the ultimate goal of the Dendrite Developer Council was to bring all of the industry leaders together to see if we can come to some common agreement about various aspects of this industry, also known as standards. Right. And so whether it's about job ticket submission, whether it's about what type of data we use and what scenario to process, and Ryan's absolutely right. When there's CAD, use CAD. When there's medical imaging data, use the DICOM data, right? Like these are existing standards. We need to interface with them and figure out what's the most efficient way to go use this going forward, right? And that's our goal. It's to kind of become the nexus where all data comes in and eventually gets manipulated to go to the machine, right? It's why, you know, you'll see oftentimes people compare us to kind of like Adobe PostScript from the 1980s, right? We're taking in all of the data that's coming in, whether it be perfect from CAD land or from the medical imaging side, you know, from the scan data, and transforming it into something that a printer can consume, right? And in order for all of that to work, we all have to agree upon interfaces. And ideally, we don't have 15 different interfaces just because everyone wanted to make a special proprietary file format for every aspect of what they're doing, right? There is something to be said about having proprietary data, right? But it's a question of where does that line lay and how can we use that line as a benefit to honestly everyone in the industry as a whole.
We'll stick on standards. Multifaceted question. I want to get both Ryans in on this too. So for you, Harshil, with the Developer Council, do you have enough critical mass to get agreement that could become standards for job tickets or whatever? And then for the two Ryans, have you been party to any of these conversations about what should we standardize on? And what are your thoughts on Dendrite's ability to be a facilitator of standards that are created through the voice of multiple parties through the developer council? So first to you, Harshil, do you have the critical mass?
So I think we have the critical mind share, right? Of course, these things take time. So I think we're just broaching the subject at the moment. But to give you an idea, even at the last developer council meeting, where we talked about our toolpathing API very publicly, with the council members, immediately the notion of creating a toolpathing working group was formed, right? In fact, Andreas at SLM, who attended, asked if we could make that working group, right? And so I think there is an appetite here. I think how we make these standards, how we evolve them, and how we talk about them is still a little bit murky at the moment. But to your point, Todd, the first step was to get everyone in the room. And I think we have everyone in the room now, right? And now we're going to work together to figure out what we can do to honestly improve the lives of everyone.
Ryan, any exposure to standards effort or these conversations?
You want to go first, Ryan P? Yeah, sure. So I guess on and around 2009, right, was when ASTM, the F42 committee was formed for standards. So I think the industry now, and there are close friends of mine who participated, quite a lot more in the standards effort. But I think there is understanding across the globe and critical interest in developing these standards as these parts are now being, produced for end-use manufacturing, and so the need and desire and now the process is well established. So I think beyond standards, I think Harshil mentioned it earlier that just in automation of the workflow, it just helps immensely. I mean, my students spend hours and hours and hours on preparing parts and going from software. We can't even CAD a part now when we have a lattice structure and another using one CAD package. We got to import it in another and do all these things. So again, not that Dyndrite's going to solve the CADing issue, but when you talk about time and the simple labeling that I described, when they can improve the workflow, it helps enable the industry for this disruption. And so as I appreciate your question, Todd, about it, getting quickly associated with standards. When I started and you started, right, we weren't really talking about standards. This is a relatively new, it's a decade old now, and we're all getting older in this, but I think I think you're exactly right. Having them leverage what they're doing from an automation and standards perspective is incredibly valuable.
HP is involved in a lot of standards, from definition of digital manufacturing to quality standards, 3D scanning to 3MF and protocols. And I think the critical question that we're kind of getting around here is, people are at the table now, I think, to that point, but then I think to make it standard meaningful, I've worked in standards in my career. USB-C and Bluetooth Low Energy were some of the standards, and I think those technologies were ripe where the companies that participated understood a need to not everybody reinvent the wheel, the cost associated with that, and how it wasn't serving the market. So I think there's a broader agreement within the additive industry that there is a level of maturity that needs to be brought to bear, and that standards play a role in that. But I don't think it's been accurately kind of discussed yet to the level needed, where you really start to see the dominant standards shake out is what is everybody's IP, and where do they get to protect, and where does that standard support their business initiatives, and where does that standard kind of cause them, what is that standard asking them to give up about their current business or their current proprietary approach to these things. But I think that's the next conversation that we need to have, is to say, hey, how do we create an environment where every OEM, where every design vendor, where, you know, everybody that wants to, every ISV wants to come together and say, this is what I do well, and this is how I plug into a bigger ecosystem where I get more leverage, I get more scale, I get more access. You know, that is what's going to be necessary to get this entire industry to the point where we're a serious alternative to analog manufacturing, you know, across end goods, right? Across consumer and medical and aerospace and industrial. And I think HP is very, very much in favor of that, because again, that's the path. You know, one of the key enablers to getting this industry to the scale that HP wants it to get to.
Excellent. Thank you. Want to reserve some time for questions, but I don't want to cut off the conversation. Trying to decide how to play this right now. I do. I'm going to go ahead and ask this question. I'm just debating this. So, Harshil, if you've got a collection of companies talking about what these standards should look like or what we should coalesce around, is there any way other than being a member of the Dendrite Developer Council to have input to this conversation of what we should coalesce around? Or is it closed doors and you're either a developer council member or you're not?
So I'd say at the moment there isn't, but it's my full intention to change that, right? In the same sense that, like, you know, Adobe PostScript, for example, was a standard in the industry. The entire specification was completely open source and anyone could look at it and vote on it and talk about improving it, right? And so for example, right, there are a number of companies in this industry, whether they're simulation, you know, software companies, or they're like binder jetting DLP, you know, like photopolymer companies, they all effectively need voxels in some way, shape, or form, right? There's no intent here to patent the concept of voxels, right? All we need to agree on is a generic methodology on how they're represented, constructed, and that data can be accessed, right? There's nothing fundamentally there, right? And to buttress what Ryan was saying, it simply just needs to be done in a careful way so that we don't hurt any of the people who are trying to make businesses here, right? Because I'm sensitive to the fact that we are going right up to the line of where people start to get comfortable here, because all their IP is usually tied at those core fundamental levels, right? But to that end, everyone knows what voxels are. You know, if we can just agree, for example, on a way of modifying them, transmitting them, and accessing that data, right? That's nothing that anyone is really patenting. They can patent all the data they put in them, for example, right? And how they generate them. But the key aspect of knowing that it exists, you know, is not necessarily a patentable concept, right? And so to that end, my goal is to figure that IP question out that Ryan was talking about in the closed door setting, get everyone excited, and then sort of open the coffers, if you will.
Thank you. Very cool. Well, I want to leave at least 5 minutes for questions, but let me just open up all three of you. Any closing comments, anything that we didn't touch on that is just you're dying to share with our audience? Or did we cover it all?
No, not from my side. I'm happy to move to Q&A.
Okay. Ryan W., you good?
Q&A is great with me.
All righty. So we will move to Q&A. As a reminder, in the Zoom window, if you've got a question, go to the bottom of the screen and click on the Q&A button. Now, we've only got 5 minutes. I suspect there's a lot of questions we're not going to be able to get to. I've asked the Dendrite team if on the back end they could compile those questions, get them answered, and then distribute them back out to our attendees, and they have agreed that yes, they will. So anything we don't address here, Dendrite will get to after this session concludes. Our very first question is from Dean, and this is going to be a fun one. This is for Harshil. Dean says, the penny has finally dropped what Dendrite does. It's magics, isn't it? But developed in the US and not Belgium. Please explain.
I'm sorry to disappoint you. It isn't that. What we provide is a way maybe to help do those kinds of, you know, operations and things. But we Dendrite are not selling build prep or build processor software. So I'm sorry, that's wrong at the moment.
And I got to apologize. I'm looking at the channel of questions there. I said Dean. It's actually Al Dean who posed that question. Al, thanks for the question. Next up, related questions. Randall Newton asked, Dr. Michael Greaves told me recently that QC for additive manufacturing is currently more about specification control than true quality control that manufacturing expects. Can Dendrite help?
So I can touch on this a little bit here. So from a QC standpoint, right? Like we're talking about data generation, right? We are already talking to a number of sensor data companies asking or interested in being able to take that sensor data and operate it and use that data in the same environment as all of the other CAD CAM data, right? And so while that path isn't immediately obvious and clear yet, at least to me, there is an intent on our side to be able to take in that data, manipulate it, and view it in an overall environment. I'll also make a point to say to any of the folks in the press in the room, more than happy to pre-brief you on what's about to happen in the next 2 months.
I'm going to treat, we've got two other questions related to real-time monitoring, melt pool monitoring, so forth. I'm going to treat those as addressed, at least loosely, by what you have. Sarah, can you feed me any other questions? We'll move beyond Suchi's and Adam's question. All right, next question is from George Newman. Is Dendrite looking to improve the processing software from OEM printers to speed up the build prep process? And there's two questions it looks like. So that's number one. Is Dendrite the future is Dendrite the future software to allow engineering and manufacturing a better way to design for additive and build consistent parts? So first question was, is Dendrite looking to improve the processing software from OEM printers to speed up build prep?
So on the first question, we are already looking at licensing our key engine technology to a number of the printer companies so that they can run the software on the machine itself, right? The idea here is if you have the sensor data and we can crunch that data quickly, then you can use it institute process monitoring and control, right? You can also then not send over 4 or 5 terabyte files to the machine. You can simply send much more compact data to the machine and it can create it on the fly as it needs it, right? So that's sort of what we're doing there. On the enablement of repeatable and reliable workflows, I'd say technology that is built, software technology that is built on our software backbone is going to, by definition, enable those things, right? And you'll just have to stay tuned for what I'm talking about.
Thank you. Well, we're going to take one more question because I want to respect everyone's time. Last question is from John Callan. How soon, in all caps, do you see AM moving away from the faceted representations to a higher level representation? Is this constrained by the motion systems on the AM machines? Do you see a similar evolution that was realized with traditional CNC machining?
So it's actually not totally constrained by the motion systems on the machine. Most people don't know this, but there are a number of companies out there, even in FDM land, who have motion controllers that can print splines, right? So they're, having specific, facets and things is not necessarily needed. Even, for example, with the HP machine, right? HP machines are not printing polygons, right? Like you can just look up on the internet what HP machines are printing, right? And so I think we're actually already there, right? We just need to unlock the door, if you will. And I can't say how soon without breaking and violating a bunch of NDAs, but let's just say it's soon, very soon.
Very good. Well, that's going to be all that we can take here. I want to wrap things up. Sarah, could you pull up that last slide? And Harshil, keep your mic open for me. So I want to thank all of our guests for joining us in this discussion. I think it was very beneficial, very insightful, and I hope you found that I did a good job as a host keeping it from being a sales pitch by anyone. And with that, I want to thank each one of you for attending and listening in, and just challenge you a little bit to take this conversation and kind of dream or brainstorm or envision what these kind of developments can mean for you in your additive manufacturing environment. So we've got the last slide up. This was playing before we opened up the mics and did the session. I just want to let everybody know that there is a Dendrite Day coming up on October 29th. On this screen, there is a URL that is a link for registration for Dendrite Day. And I believe there's also a little contest where you, on that website, where you might be able to score some swag. At least that's what I've been told. But Harshil, the reason I wanted you to keep your mic open, is there any teasers that you can give us that would motivate people to go ahead and register for the 1029 event?
Just that a lot of really cool stuff is about to happen. Keep your eyes peeled. You really want to come. You're gonna want to come 1029. And I'm genuinely excited. A lot of stuff is going to come to fruition over the next month and a half. So stay tuned.
Wonderful. Wonderful. I'm looking forward to it. I hope all of you are. Again, thank you very much for your time today, and enjoy the balance of your day, and good luck with your additive manufacturing initiatives. Take care, everyone.